Hello, we are the Modest Bad Apples, and today we'll be discussing the topic of variable frequency drives, or VFDs. Today we'll be discussing why ASU needs these variable frequency drives, and our target audience will be the VP of Faculties and Development and Management. The purpose of the benefit for ASU to use VFDs in their existing infrastructure is to help maintain their #1 in innovation status for the coming years.
Hi, we're the Modest Bad Apples, and my name is Brennan. I'm the lead engineer for this project. I'm also in charge of making the video and the graphics, and my Colby A assessment score is 7445.
Hi, I'm Samantha. I will be in charge of research and writing of the report, and my Colby assessment is 7626.
Hi, my name is Joseph Garcia. I'm responsible for quality control and additional research. My Colby A is 8633.
Hi, I'm Raymond Potts, and mine is going to be over equations like present value, future value, etc., and financial specialist. My Colby A is 8624.
So, what do variable frequency drives do? A variable frequency drive is essentially a waveform converter that allows you to modulate the frequency for an alternating current motor. This in turn, it also gives you the ability to modulate the motor's speed. And the faster a motor is spinning, the more power it's consuming, the slower it's spinning, the less. Now, depending on the application, this can usually generate this usually opens the way for a lot of energy savings potential. Now in the diagram we see on the left, you just have your sine wave power from the utility company or from the grid. And then the power is effectively converted by a variable frequency controller into something that sort of resembles a square wave, but the frequency is modulated all the time, so you effectively are changing the speed of the motor. Now, not all AC motors can handle this modified square wave, but for the most part, they usually can.
Some of the potential obstacles of VFDs is that some infrastructure, the ductwork within a building, can't handle the reduced speed flow that would come from having a VFD. They need that higher speed to meet minimum requirements for airflow, and so installing a VFD would be pointless and wouldn't have any benefit. In addition, some motors are not compatible with a VFD, and so to put that in the system, you would have to replace the motor in addition to adding the VFD.
Alright, some of the tasks remaining we have for completing this technical report is a little bit on history. And the VFD is the predecessor to rotary machines. It has become more affordable and widely available due to improvements in solid-state technology. Some of our average costs, as well as maintenance costs, roughly a VFD system is about $1,000 upwards to $5,000. And it may be cheaper to either retrofit or update existing systems. And we want to look into a little bit of that and compare and contrast to see which one's better. Some of the potential plans are lump sums for our future values. So we need to see if it's easier and better for that company to purchase it from a lump sum or have a payment plan set up, and which one would be better and beneficial for the company.